So, one expression that represents the area of all rectangular pig pens made from the 27cm strip is this. The expression is in terms of the pen's primary side length. What use could there be for such an expression? Well, obviously we could use it to calculate the area of a pig pen with any primary side length we like. The structure of the calculation is done for us. We do not have to recreate it. Suppose we chose the primary side length to be 2 cm, we could calculate the area in the following way. How does changing the value of the primary side length x change the area? Let's increase the length to 4.4 cm. So, as the side length increased, so too did the area. I wonder if an even larger side length would lead to an even larger area. Instead of doing one calculation at a time, we can make the calculator do many at once and display the results in a table of values. In table mode, we can enter our area expression. Notice that y1 here is representing the area of the rectangle, just as x is representing the primary side length. For our primary side length, we can start with the smallest possible value, which is 0, although that might not leave much room for our little piggies, and got to the largest possible x value, which is 13.5. The lengths in our table will increase in regular increments or steps. I'm going to choose a step value of 1 for now. What can we learn from these areas? We can see that initially the area does increase as the primary side length increases, as we saw earlier, but at some point the area starts to decrease. Interesting. What did the shape of the pig pen seem to be when the value of the area started to decrease? If you were not watching the animation, rewind, watch it again. So, now we know that if we choose small or large side lengths, the area of the pig pen is smaller, but for values in between, the area is larger. A rectangle with larger area will give our piggies more room to move. So, what primary side length should we choose to give them the maximum room? We can figure this out by being more strategic with the areas we choose to calculate. For example, we can start the table at 5 and end it at 9 with steps of 0.1. The biggest area shown in this table is 45.56 square centimetres. This seems to occur for primary side lengths of 6.7 or 6.8 centimetres. But which is it? Or is it a different value? Maybe in between 6.6 and 6.9? At first glance, it looks like there are lots of rectangles with the same area, but looking more closely, we can see that the biggest rectangle in this table has an area of 45.5625 square centimetres, and it has a side length of x equals 6.75 centimetres. So, is that the maximum space for our pigs? Or can we do better? You can investigate this further. I'm off to build a pen like this. What shape does that pen seem to be? I wonder how things would change if I needed 2 rectangular pig pens, as I might in a bigger pig farm, and I was going to build my pens something like this. As part of this resource, you can download a task in which you are challenged to consider the area of 2 or more adjoining pig pens. Take a shot at maximising the piggy's wiggle room in the situations presented.